YourPedia. My name is Aman Sharma and I am your mentor for CSC at YourPedia. So this video is regarding the demo lecture for NIC. So in this video we will be covering a topic from the syllabus of NIC और उसके बाद we will be doing some questions on that topic, and after that at the end we will be solving some previous year questions that were asked in the Scientist B and the technical assistant vacancy of NIC, and then we will compare the difficulty level of the question. So the topic that we will be covering today is CPU scheduling from operating systems. Now what is CPU scheduling is, so there are multiple jobs that come into CPU, and it is the job of CPU to provide them the it is the job of long-term scheduler to provide them the CPU in such a way that the execution is done in a correct way, or you can say that there is less waiting time, there is less turnaround time. So all the things are kept to the minimum in order to get the most efficiency out of the system. So in order to understand what is CPU scheduling, first we need to understand some of the common terminologies used in CPU scheduling. So the first terminology is arrival time. So arrival time से क्या मतलब है? The time when process arrives in the system. After that, next is burst time. Burst time. So burst time is the time required by the job. Required by the job to complete its execution. Next is completion time. Completion time is the time at which the job will complete its execution and will leave the CPU. So when job completes its execution. Now these are the three basic times. After that, the next is turnaround time. Turnaround time. In most of the questions, turnaround time will be asked from you. So turnaround time is nothing but the time that job has spent into the CPU. So you can actually get an idea. So the job will enter the CPU at arrival time and job will leave the CPU at completion time. So turnaround time is nothing but completion time minus arrival time. So this is the time for which the job was present in the CPU, whether it was executing or not, but it was present in the CPU. So either it will be executing or it will be waiting for the waiting to get the processor. So turnaround time is completion time minus arrival time, and last is waiting time. So the time for which job had to wait while being in the CPU. So the total time in which the job was present in the CPU is turnaround time minus the time for which it was actually executing the job, which is burst time, time required to execute. So turnaround time, the time for which the job was present in the CPU minus burst time is equal to, minus burst time is nothing but the time for which job was executing. So the remaining time will be equal to waiting time. So these are some of the times that we normally use in order to find the best possible solution for CPU scheduling. Now after that, there are multiple algorithms, or you can say multiple methods to apply CPU scheduling. So the methods are first come first serve, first come first serve. Next is shortest job first. Next is shortest remaining time first. After that we will study round robin. Then comes preemptive scheduling, sorry, priority scheduling. Priority scheduling with non-preemptive criteria. And next is priority scheduling with preemptive criteria. Now what is preemption and what is non-preemption? So let's say that a job enters the CPU and it gets the processor and starts executing. Now let's say that the job needs 6 nanoseconds of CPU, and when it has been executing for 2 nanoseconds, a new job comes into the CPU which has higher priority to the previous one. So if it is a preemptive scheduling, this job will execute for just 2 nanoseconds and will come out of the CPU, and the processor will be given to the process 2. So this is P1. So if in CPU, if P1 is executing and it has executed for 2 nanoseconds, and after that a job comes which has higher priority than the P1, then P1 will be pushed out of the process, pushed out of the CPU, and P2 will be given the processor. But if it is a non-preemptive scheduling system, in non-preemptive what happens was, let's say that a process comes which has higher priority. So no matter which process comes, first P1 will execute and completes its execution time or burst time. After that, after only that P2 will be given CPU. So in preemption, nor in layman terms, preemption में अगर कोई जॉब आ रही है हायर प्रायोरिटी वाली, तो हम कम प्रायोरिटी वाली जॉब को उससे स्वैप कर देंगे. If or in non-preemptive, what we do is, first the job that is being executed in the CPU will complete its execution. After that P2 will get its turn. So these are some of the algorithms, and if you divide them on the basis of preemption, first come first serve is a non-preemption. If a job enters the CPU and starts executing, it will complete its execution, then it will leave the system. After that, shortest job first is non-preemptive, shortest remaining time is preemptive. Round robin is also preemptive. Priority scheduling, as the name suggests, non-preemptive, and two types of priority scheduling are there, non-preemptive and preemptive. Now we will move on to some next. We will start studying first come first serve, and we will try some questions on this. Now what is first come first serve? First come first serve. So the criteria for the first come first serve is arrival time. Now we will, criteria is arrival time, and mode is non-preemptive. So this is the important part here. So the job which will arrive in the system first will be given the priority. So what do we mean by criteria? That the job which has arrived first into the system will be given the processor first and will be given the priority over the job that has come after that. So we will try to solve a question on this. So let's say that you have these number of jobs: 1, process P1, process P2, 3, 4, 5. After that, the arrival times of the jobs are 0, 1, 2, 3 and 4 seconds. Burst times of the jobs are 2, 3, 8, 4 and 5. And it is saying what will be the average turnaround time for this job. Now we will use Gantt charts in order to make these, in order to solve these questions. So how does the Gantt chart works? So the Gantt chart is, now initially at 0 only one process has arrived into the system. So P1 will start its execution. We will write completion time here. Now this is a non-preemptive system. So no matter which job arrives, the job that arrived at the earliest will be given the priority and will complete its execution because it is a non-preemptive job. So it will execute for 2 seconds. So for 0 to 2, P1 will be there and it will leave the system, and the completion time for P1 will be 2 seconds. After that, at 2 seconds, 2 new jobs have arrived into the system. So which jobs have arrived into the system? These are the arrival times of the jobs, and the jobs that have arrived into the system are P2 and P3. Now out of P2 and P3, which the criteria that we use in this is arrival time. So which jobs arrived first? P2. So P2 will be given the CPU. So P2 will be given the CPU and it will complete its execution for 3 seconds. So if it started at 2 seconds, it will complete at 5 seconds. Now at 5 seconds, all the jobs into the system, all the jobs have arrived into the CPU. These jobs have arrived into the CPU, P3, P4, P5, and the arrival times are 2, 3 and 4. So the lowest arrival time is for P3. So P3 will be given the system. So it enters the system at 5 nanoseconds, 5 seconds, and it requires 8 seconds of time. So if it requires 8 seconds of time, it will run till 13 and will be completed. So P2 completes at 5, this completes at 13. After that, P4 will get the CPU and it will run for 4 more seconds, 17 nanoseconds, and after that P5 will run for 5 more seconds, which is equal to 22. Now we have found the completion time of all the jobs. Now what is turnaround time? Turnaround time is nothing but the time that the job spent in the system. So it completed at 2 and it arrived at 1. So turnaround time is nothing but completion time minus arrival time. So the turnaround time for this is 2. For the second is 5 minus 4, which is equal to 4. 13 minus 12 is 11. 17 minus 3 is 14 and 22 minus 4 is 18. So these are the turnaround times. Now the question is, what will be the average turnaround time for this system if we use first come first serve? So average turnaround time is nothing but 2 plus 4 plus 11 plus 14 plus 18 divided by total number of jobs, which is equal to 5. So 49 divided by 5 is nothing but 9.8 is the average turnaround time for our system. Now let's see another question on this. Now the next question is, let's say that you have 3 jobs and the arrival times are 0, 1, 2, burst times are 21, 1, and you have to find the average waiting time for this. So P1 will come first into the system and it will run from 0 to 20 seconds. So completion time for P1 is 20. After that, for 1 second we will give the CPU to P2 and 1 second for P3, and you can also find the turnaround time. Turnaround time is nothing but 20 minus arrival time is 20, 20 and 20, similarly for this one, and waiting time is nothing but turnaround time minus completion time, turnaround time minus burst time, the time it was waiting in the system. So 20 minus 20 is 0, 19 and 19, so which is equal to 38, and average waiting time is nothing but 38 divided by 3, which is equal to 12.66. Now if we do some little changes in this, now the changes we are going to do are, process ID is 1, 2, 3, arrival times are same 0, 1, 2, but burst times have been, order of burst times have been changed. So in this completion time will vary because we have changed the pattern of this. So at 0 P1 will come and will be completed at 1, P2 will be completed at 2, and P3 will come and be completed at 22. And if you look at the turnaround time, which is nothing but completion time minus arrival time, so the turnaround times will be 1, 1, 20, and waiting time for the jobs will be turnaround time minus burst time. So turnaround time minus burst time is nothing but 0, 1 minus 1 is 0, 20 minus 20 is 0. So the average waiting time is 0 nanosecond for this system. Now, what we have learned here, if a job with higher burst time comes before the jobs with the low burst times, the waiting time of the system increases. But if we handle the low burst time jobs before the high burst time job arrives, then the waiting time of the system will be less, or in this case it is equal to 0. So this is nothing but, this is called, the definition for this is convoy effect. So convoy effect, nothing but convoy effect is the effect that in first come first serve, if the first process is having, if first process is having higher burst time as compared to the other jobs, the waiting time will be increased significantly. So this is a convoy effect, and first come first serve suffers from the convoy effect. Now this is the algo first come first serve. After this we will study shortest job first, but first we will try some questions that were asked during the interview of technical assistant A and technical and scientist B. So first we will focus on the questions that were asked on the technical assistant A, which are more of a theoretical questions. So the question number 1 that we will be doing is, which of the following statement is true? Which of the following statements is true? First statement is, first come first serve is non-preemptive. Second is, round robin is non-preemptive. And third is, shortest job first is non-preemptive. Shortest job first is also called SJF, and the shortest remaining time first is SRTF. So which of the following statements are true? And there were some options given. Now we know that first come first serve is non-preemptive, which is true. Now round robin is not non-preemptive, and shortest job first is also non-preemptive, because the preemptive type is called shortest remaining time first. So this is not the algo which is preemptive in nature, it is non-preemptive in nature. Now when you study CPU scheduling and you will be doing some questions on all of these algorithms, first you will study those algorithms and then you will do questions on those algorithms, then you will see how easy it is to remember, because when you have applied the algorithm, you know that it is non-preemptive, it is preemptive, it is non-preemptive. So then there will be no need of cramming in that case. So you will be pretty easily be able to answer those questions. So for technical assistant, the question will be a very theoretical type of question, not a numerical kind of question. So another question that came in the exam for technical assistant was, which of the following suffers from convoy effect? So the options were round robin, shortest job first, first come first serve, and shortest remaining time first. So if you have studied first come first serve and you have tried the question, you will be pretty easily be able to answer this question, that first come first serve will be suffering from convoy effect. Now let's try another question which was asked in the scientist B interview. So for scientist B, the question was, consider four processes have been given to you, P1, P2, P3 and P4, and their arrival times are 0, 0.6, 3.8 and 4.4, and the burst times were given as 8, 6, 4 2, and it is asking what will be the average turnaround time for this this condition when you apply first come first serve algorithm. So it is asking, just asking average turnaround time for first come first serve. Now if you start solving this using the Gantt chart, so initially there is only one process in the system, so P1 will be given CPU as there is only one process that has arrived, and it will be given the CPU, and it will complete for 8 seconds because it is a non-preemptive system. Now after 8 seconds all the jobs have arrived in the system. When all the jobs have arrived, the priority will be given to the job which will be having least amount of arrival time. So the arrival time is least for P2. So P2 will be given priority, so it will be completed at 14. After P2 is completed, next job which has arrived after P2 is P3, and it will be completed at 18, and the last will be completed P4 at 20. So these are the completion times for these jobs. Now if you want to find the turnaround time is nothing but the time that job spends in the system, whether it is waiting there or it is executing. So it will be completion time minus arrival time when the job arrived and when the job left the system. So completion time minus arrival time is nothing but 8 minus 0, 14 minus 0.6 is 13.4, 18 minus 3.8 is 14.2, and then 15.6. And if you try to find the average turnaround time, it will be nothing but 2, 1, 2, which is equal to 51.2. So average turnaround time will be 51.2 divided by number of jobs, which is equal to 4. So 1, 11 to 8, 3.2 is 12.8. So the options given were, so the options that were given in the question were, first option was A 15, second was B 12.8, third was 13, and the last option were none of the above. So the correct option will be option B. So as you can see, the type of questions that comes in technical assistant and scientist B are little different. You have to study the same concept. So in order to solve this question, you have to study first come first serve, and when you study first come first serve, when you start studying first come first serve, you will be studying these things, that whether it is a non-preemptive system or not. When you study this, you will be studying how to solve this by using the algorithm. After that, you will be studying what will be the convoy effect. So when you study the whole topic, the questions that will be of theoretical nature and will be of less difficulty will be asked in the technical assistant part, and the questions will be which will be of a higher difficulty will be asked in the scientist B. So when you thoroughly study the topic theoretically and numerically, you will be able to answer the questions asked in technical assistant and scientist B both. So I hope you understood the concept that I have taught today, and if you have any queries, you can write down it into the comments, and I will surely try to help you out. So keep watching and keep preparing. Thank you.